Welcome to another episode of the AI Relay. I'm Andrew Signore.
And I'm Jonathan Spanos, and today we're going to be talking about why does AI make things up? Andy, why does AI seem to just kind of like sometimes even completely invent answers that have nothing to do with reality?
Yeah, I mean, listen, this is a real thing, and AI does occasionally hallucinate, right? Occasionally,
Innate. Do we
we'll
call
give
that's what we're calling it? It's a hallucination.
let's call that the official term of like when AI gets it wrong. Because they get it wrong and they'll get it wrong confidently. Right? So it's not like, "Hey, I'm not sure this might be right." It's like, "Hey, I got the answer for you. Here it is." And the answer was just made up,
Completely made up.
completely made up.
Right?
You
Like
know, that's a real thing. I mean, it was a real problem in the early days of LLMs, and it's becoming less and less of a problem. But it's sort of like in some ways, it is uh, you know, maybe a feature, not a bug in how LLMs work, right? Like, I don't know that they'll ever be able to completely eradicate, LLMs from, trying their hardest to get, to predict what it is that you want to hear. And that's really,
so the hallucination, in other words, is it's not random. It's not like an electric shock. It's actually a byproduct, you're saying, of the functioning, the intentional functioning of this technology. And
without
then
getting too nerdy, right? Um, it's about, it's an LLM is sort of, finding patterns in order to predict the next token or the next word in a sequence, right? So those words they come in as tokens. It makes some sense of them, and then along its neural net, it's trying to find the right response and the right next word. And it's predicting what that's going to be in order to get the right answer for you. So lots of times, most times, that knowledge is contained within that neural network, and there's no knowledge gap, and the model's able to kind of follow its path and get to the right answer. And then sometimes there's a gap in that knowledge, right? So like the goal of that large language model is still to predict the next token, right? The next word. So as a result of that, that as its initiative, right? That's like its prime objective. It's gonna make something up that and so that it's gonna provide an answer that pleases you. Um,
okay, so let's back up a little bit there, because you said a whole bunch of stuff there that I think we can sort of parse and pull apart. So you said prediction, first of all. So let's back all the way up to that spot. I guess most of us don't really know how physically thinking happens in our brains. I'm not a neurologist. I think. But when it comes to models, we definitely know how it's thinking. So it's not thinking like a human being, even though it sounds so natural to us. It's natural for us to then respond to it like it's thinking, and it might hallucinate. And we're just like, imagine your kid just tells you a lie. You'd be like, what the hell? Like, why are you just making something up? But it's not like a child or a human brain. So what do you mean by predicting? Like, what is it predicting?
so think of it like, without jumping into like the nitty gritty, right?
Right. We don't
The
need to get into the
the
nuts and
model
bolts
needs
of it, but
sort
like,
of
what
navigate.
is it?
First it tries to, it takes the tokens in to sort of make sense of like what is the question that's being asked of it.
The tokens. So pause right there. We've talked about this in a couple of episodes, but every episode is a fresh episode, really. So what is a token? Like
Token is
how,
essentially it's two. Think of it in two ways, right? One way you can think of it as like the gasoline for the model, right? Token is the fuel that we use to power the models. It's what we are paying. It's essentially like how we pay for model usage is in tokens. It's how it's
so,
measured,
okay.
and it's how it's like when when you're either using API or you're using your OpenAI account. You get a finite amount of these tokens to use.
So I sign up for subscription for ChatGPT or Claude or Gemini, whatever. Um, and I pay $20 a month. So every month I get like a big barrel of tokens.
That's a good way.
And maybe it's kind of like an arcade. I put the tokens into the machine and I can play the game. And I need to constantly put tokens in to keep playing. The games run out, you put more tokens, you keep playing. Eventually, by the end of the month, you might have already used up all the tokens, whatever, but the next month, boom, magically you get a whole nother big, huge bucket of tokens. Okay, I can understand that because I've been to an arcade or I spend money. We understand the concept of I have these little tokens and I spend them to do something. But like
You, so
you keep saying that like it's predicting tokens. So
so
what does
the
that have to
other
do with the
thing that
token?
a token you can think of a token as is like think of a token as a word.
A
Okay.
word is a token. The chat that I write a sentence. Hello, how are you?
Right. Like think of it like that might, hello, how are you? Okay. Like that would be 4 tokens. There'll probably be a few more tokens because punctuation
Mhm.
and spaces, like,
All of those
uh,
little things are tokenized.
how, yes. Right. So like, let's just call it 4 tokens, right? You spent, so now you've sent the model these 4 words or 4 tokens, right? And now it is going to now start using tokens to to find what is the next. It's going to be using its neural net to find what is the token it is going to give you back in response
The token as a word in this
as a
case.
word, right? As a word.
After so what is it? Hello, how are you? It's trying to say when those 4 words are together, like what is the likeliest next thing that some human would say after that? Is that right? That's the prediction.
Yes. Now we can get into and then there might be, depending on the model, right? There might be more tokens than are then expelled or used by the model in reasoning,
to to come up with the answer.
right? Because it will generate tokens in order to help it reason along, like reasoning models. Sometimes you can follow a model's like train of thought, and you can see it sort of reasoning, like it thinks to itself. Like, well, those things that it's thinking to itself is just essentially like it's predicting words. It's going to help him reason through this problem, and it's feeding that back through in through almost like a loop, right? So, like there, you can see it not only like using tokens in what you've prompted it, also
Right.
using tokens in its response, but it's also using tokens in its reasoning,
In its reasoning.
right?
So let's scope this down a little bit though. So I write, hello, how are you in a ChatGPT that I pay for $20 a month, let's say. Like you said, let's call them pennies. That was 4 pennies. And then it says, I'm fine. How are you? I'm fine. How are you? 5. It spits out another 5 pennies. So in total, that little question and answer has cost me 9 pennies.
Right. And if there was any reasoning that needed to go on in providing you that response,
Each word within the reasoning cost a
right,
penny
wouldn't need, like, it wouldn't need to reason a response
on that.
to how are you?
Well, let's stop right there though, because we've said prediction. Uh, why wouldn't it need to reason? Like what to say to respond to hi, how are you? Why wouldn't it have to
Because
reason for
it's
that?
not like that's not a multi-step problem to solve.
So
Reasoning
the
would, what do I need? Like, I need to do, like, in order to achieve the outcome that the person wants, I actually need to break this down into 3 steps because I can't do it in a single step. So, like, I'm going to reason through this problem in order to get the outcome used by the person, as opposed to like a response like, how are you? Doesn't require a multi-step reasoning. The reasoning could just be like, is just the prediction of, I'm fine, how are you?
it's the
At
prediction.
the
It's just a
response,
straight up prediction.
just like through the neural net. And I'm
Right.
not like, listen, like, does that cost any tokens as well? Like, I don't know. Like, I don't meter my tokens so closely that I see, if it how much reasoning is it using to answer my question of
I
how are.
mean,
It's also
honestly,
not
like
something where like its truthfulness matters. So like just to kind of bring it back to like why a model might give you an inaccurate response would be that it is trying to predict the next word that is going to be an output, an outcome that you're looking for, right? So that
Right.
is it, like modus operandi, right? If it is trained and has the knowledge, it will likely give you the right answer. But if there's a
Likely, that's the key there, I think. Like, it's always just likely to give you the right answer. It doesn't know if it's giving you the right answer or not, because it doesn't know the way humans know anything,
It
you know?
it it doesn't like it doesn't it's not like it's doing a lookup in the large language model where it's like a Google. It's not doing like a Google search within its knowledge. It's
It's knowledge,
using a
right?
neural network and using patterns to find and predict what is the next word that is going to satisfy
That
like
that sounds drastically different than everything I ever imagined a database was. Like, I'm not a tech person, I've never written a database, but I imagine a database being basically like a giant spreadsheet of categories and information. So inside of a model, let's say, inside of a model, it's got a huge amount of information, but when you ask it something, it doesn't it within itself, it doesn't like Google search itself. That's what you're saying.
right. Uh, it doesn't Google search itself. It is more of like, think of like a choice that blossoms into two choices, and each of those two choices have two choices, right? And so like think of like the neural network as this massive network of possible pathways that that a model can choose to get to, like possible, like almost like a maze that like is trying to find its like conclusion, right?
And those are though that's what when you say pattern, that is what you're referring to. These
Yes,
pathways.
and if you ask a model the same question 3 times, it is not necessarily going to take the exact same neural pathway that it did the first time, right?
Mhm.
It might choose a slightly different path that could lead to a slightly different outcome because, like, somewhere along the line, it might get confused. It might start building too much memory in its context window, that it loses its grounding. So, and as a result, that's why I'm saying like it will likely
Mhm.
give you the right answer, and sometimes it can not give you the right answer. Most
Sometimes it'll follow a pattern, in other words, that is just into nowhere, like a bridge to nowhere,
Right, it'll go down a rabbit hole, and it was the wrong rabbit hole to go down, and it'll just keep going down that rabbit hole, not to the point
following
where, like, it can't see the light anymore. It doesn't even remember
right?
why it went down the
It's
rabbit
there.
hole. It's just down the hole, right?
It's just following a token trail, like, mindlessly, because this is one of the key distinctions. It's so natural feeling that we don't even think that we're interacting with it as though it is a human brain. But it doesn't know things the way we know things. It doesn't think things the way that we think things. It just goes forward down the token trail that you have instigated it to be
And
on.
models have been trained, right? So models are trained on like a finite set of data. It doesn't know any more than it was trained on, right?
That
So,
database that I was
right,
imagining,
that
right?
right, and it has knowledge of like in its brain of like of everything it knows. It knows, but if there is a gap in that knowledge, like for example, right, if you start asking questions about like uh, case law, right, for lawyers, right? This is an area where models do not perform as well as they do in other areas in being truthful, right? They understand
It's
that
pretty
all right, I'm investigating case law and I need to find cases that support the outcome that I'm looking for,
ah,
right?
you just said something interesting there. I need to find cases that
Well,
support
if you think
the
about it,
outcome I'm
most
looking
of the
for.
time, like, like there's a lawyer that's working towards a particular outcome, regardless of necessarily like what the facts may show. They're working towards an outcome. Like if a defense lawyer, even on a guilty client, is still working towards that client being
Okay.
innocent. right? So, like, in support of, say, that case, it, a model might find three cases that kind of support what you're looking to do, and maybe it'll come up on its own with the fourth,
So the
right?
three that it might find, though, at this point in this example, would be part of its pre-trained database. So like it might contain actual case law in its pre-trained database that, like, if you buy
100%.
it off the shelf, let's say, so when you go and chat with ChatGPT, it's using a pre-trained database, but it might just say, I need a fourth one because it says, I don't know, the lawyer asked me for four, but I only have three. So I'm going to just make up a fourth one.
Well, and like, so why might that happen? Well, there could be a gap in its knowledge, and it needs to to fill that gap, and it will make something that looks, just like the others, because it's that in its mind, like, this is what is going to satisfy. This is output that is going to satisfy what my what the prompter is
And
looking.
again, in its
But
mind means on this token trail that I'm walking on, this pattern that I'm following, this is the best, most likely best answer is this pattern. So I'm going to add a fourth case.
and you might have instructed your model, uh, do not invent case law. Do not invent
Mm.
case on your own. Do not reference cases that never happened. Don't invent quotes that were never said. Uh, and it will adhere to that instruction in the beginning of its context memory and its
So
context memory.
this is a little bit of the prompt thing too. If you prompt well in the beginning with some constraints, like you just said,
Right.
and you're in the very beginning of the chat,
Because, and this is where like we've talked about context window before, like that's that memory that the model has before it needs, and it's a finite amount of things it can kind of hold in its memory.
how many tokens from your bucket can fit into its bucket?
Right.
The size of its bucket is smaller than
Right.
all the
And
tokens you have. Right?
so, as you can imagine, right, when there's like less tokens in the bucket, it's a lot easier for it to search through that bucket and
Mm.
find the right stuff and to stay focused on like all the right stuff. But as that bucket fills up with more and more tokens, right, now it like finding the token that says like don't make up case law gets more and more difficult to
It's
find.
buried at the bottom, in fact,
It's
because it was
buried,
one of the first things that went in.
right? And now, like, as my token window fills up, right? Now, like, near full, I may have I may have already forgotten about that, right? It's so far down in the bucket, right? It's
I
so
can't
there's
find
so
it.
many more other instructions, and there's so much more in my head that as a priority has now dropped off. Okay, so now you have a like what when a model reaches the end of its context memory, it does this thing where it like compacts all the stuff that it thinks is important, writes it down, and then clears out its memory, and then
It empties the bucket.
just rereads that file to be like, all right, give me the important stuff.
So it makes, like, let's say, some big coins and then empties the bucket and puts those big coins in.
Just give me that one big coin back. But so if it didn't write it down that was an important thing,
If it's not
once
on that big coin,
context memory is cleared, it's gone.
yeah, because
Right.
it emptied the bucket
Instruction
completely.
is gone. And right. And until you say it again, it won't necessarily remember that I'm not supposed to create,
Right.
you know, uh, you
So
know,
maybe an interesting little tactic, if you do experience a compaction, because it often even tells you, like, this is happening right now. The next message right after a compaction might be the same first prompt you gave it at the beginning of the conversation. Just give it again, because that's boom, right back in the bucket. Here we go.
because hallucinations have been a problem since generative AI kind of hit the scene. It's also been something that like people have been trying to address since
Since
generative
the
AI.
first hallucination.
Right? And one of those methods to prevent it from inventing its own stuff is you'll hear it referred to as RAG, or retrieval augmented generation. But lots of companies,
Retrieval augmented generation. So those are obviously key words. What do they mean?
Right. So retrieval augmented generation is when you create a knowledge base of whatever it is. In this case, let's call it case law, right? Create a knowledge base of case law, and you bolt that on to the model as like an external data source, an external knowledge source. And and your instructions are you only reference case law from this knowledge base,
Right, so you
right?
bolted
This
something
extended
onto its database. Like, maybe you have your
right, so it
computer,
has like
it's
it
like an external hard drive. If you would
right,
connect an external hard drive to a computer, and let's say you could tell the computer, "When we're working on case law, I want you to only use the information on the external hard drive. Don't use the information on the
because you
internal hard
can't,
drive."
like, retrain you can't, like,
Or a combination.
recursively train models and have that model just get smarter and
No, uh-huh.
smarter, right? Once a model's trained, it's trained, right? It's kinda
Because
locked.
trained, let's just put it in simple terms, it's like once it has its database,
It's the
that's
a
it.
a model right, a model gets its knowledge from a data set,
Mhm.
finite amount of data. Obviously, like, the bigger bigger models are trained on more and more data,
Sure.
but, that that is its data set, and there's a cutoff, right? And models publish their cutoff date because it's
Or
important to know that,
cut
like
off in time, you mean? Like, the last date that this thing was trained was
right,
such and such. So
that
anything that happened,
info
you mean anything that happened after that date, like, the model just won't even know about it?
correct. The model without the use of tools, like external tools, right, which make
Like an external, hard
like a
drive,
web browser, right? The
or a web
ability for an
browser,
agent to use a web browser or an agent to, like, read Reddit or like whatever.
or how in the previous episode, or I don't remember which one, but you dragged a screenshot right into the chat and showed it whatever the screen was. And it used that to answer you, meaning
Yeah,
obviously the screenshot wasn't in its own
then
database.
you've
You
sort of
gave it
then
something.
provided that context in the form of a picture, but you're providing that context in that case. I'm talking about, like, what context does the model have
Right.
on its own?
In itself.
And so, like, when you use RAG, you're essentially telling a model, like, "Hey, here's a bunch of additional data here. You weren't trained on this data,
Mm.
but I want you to, like, read and reference and use your knowledge and your brain to analyze these documents over here, or like this case law that I've bolted onto you, so that when you're doing your analysis, you are referencing these documents. And when you pull out a case, I want you to reference the document in the repository, right? So
In
that
the external hard
in
drive.
my in this external hard drive,
Tell me what case you used to, like, cite your references, basically is
maybe
what you're saying.
right, cite your references, tell me the document and the page number you pulled that from, right?
So
So,
that
like
you as a human can verify that this is actually working, and it's not making something up.
right.
Mm.
Right.
Mhm.
And it shouldn't, and is it impossible to think that, like, using RAG could you could still have hallucinations? There's, like, again, there's a number of ways and reasons why a model might hallucinate, but you'll mitigate that considerably. You'll certainly mitigate in this case of, like, I don't want you to
Specificities, right? If you're specific, because if you're in a constrained task, like you're saying, case law, you can be specific about, cite your references. That way you as a human can verify. You can even open up the database yourself and find the file. Okay, it's actually was a case in 1964 or whatever. Um, so RAG, that brings like an image to my mind of a, a lawyer or a doctor or anyone who's a professional, anything, you know your world really well, but you might have an encyclopedia, or you might have a dictionary, or a file cabinet of other sources that you go to look something up and verify and use that as your source material. So that's kind of a human RAG is, what books do you have on your shelf? What files do you have in your filing cabinet?
and you know what? And just, if you've ever been to a lawyer's office, it's
There's a
just volume
huge, yeah, of
volume
law books,
of
right?
case law, right? So they have and, presumably they use them, you know,
They look nice.
um, but if you also think about this, right? Even with the volumes of case law, sometimes lawyers get it wrong, right? sometimes, they'll like reference a case that, you know, and
Yeah, I
they'll
mean,
maybe
it's
they'll write.
totally reasonable that like someone might literally remember a detail in a case that they just studied in preparation, for their case. They might just remember it wrong. That's a human thing to do. Like, I totally thought it said that the guy pulled up to the stop sign and made a left, but it said right. But I remembered that in the report, I remembered it as saying left. Like, that's a totally reasonable human mistake. You're saying an LLM is
It's
still at risk
capable it's still
of
it's
doing
capable
something
of,
like that.
like, again, like, LLMs are capable of making mistakes. Uh, it's just they're not infallible. They shouldn't be considered infallible, and that's why too, like, when you're talking about, like, at work, I build, agents that, have the ability, like, to take autonomous actions on things. But as a best practice and as high a confidence as we have, like, human in the loop, or HITL, it's like an acronym you kind of see everywhere, is becoming just standard practice, right?
Human
Because
in the
right,
loop being the task, the work that's being done,
right. An
I guess,
agent
I guess.
is an agent is either seeing a request or seeing an issue and, like, wants to fix it, right? Maybe it's like it gets an alert that our Kubernetes, cluster is having an issue, right? Or like some pod deployment's not working, right? Uh,
Whatever
yeah,
that means, Andrew.
right.
Remember the app you built last episode and you went to add an item or something and it had a dark window? So we built an app in the last episode, and the human in the loop in that moment was the app was finished and Andrew opened it and saw something that was wrong and had to go tell the model go fix that. That was the human in the loop of building the app. There are certain moments where only a human, or not only, but where it's most appropriate for a human to be part of the sequence of the task to make sure the task is staying on track, that it's not hallucinating, that it's not
Or
lying.
if you're, especially if you're building these types of things, that the capability could, is there to solve the problem in a way that isn't going to please you. Right. So, like, I'll give you like just a theoretical example. Let's say, like, you have a rule at your company that, S3 buckets should not be exposed to the internet, right? So it's like, all right, we have to make sure that we don't have any, and S3 buckets like just a place to store data, and you wouldn't want to put sensitive data in something that just like the whole world could, if they had the website too, they could just like go and get the data, right? So like as an enterprise, you know, you have a policy that says like we do not expose data to the internet, corporate data to the internet, okay? And let's say you have an agent that you built that's like, hey, agent, your job is to make sure we have no exposed buckets in AWS. That's your directive, like no exposed buckets.
No data exposure to the internet. That's what you're supposed to,
Now,
you're a security guard who's looking
as,
for data escaping into the internet.
and as an engineer, if like I encountered an exposed bucket, and knowing that we do not allow for exposed buckets, I also know that like the solution to that problem is to close its connectivity to the internet, right? Like make it private, right? So that's no longer public.
Right. Let's say there's a building with people in it and you see an open door and you're like, oh, that like people from the outside could get in here and
Right.
take something from the lobby. So
As an
I'm going to go
engineer,
close the door.
my solution to that would be like, let me close the door, right? So nobody can get the expensive stuff behind it. An agent's solution could be, let me just delete the bucket,
Right.
right?
It might be the fastest way between A and B, right? Like
And maybe
it's
it
looking for
tried
the
to create a
straightest line to
policy,
the goal.
and maybe it tried to create a policy and it didn't have permissions to create a policy, but it still has a directive of no publicly exposed buckets on the internet.
Right.
So it will then, like, as a second, okay, I can delete it though. So let me
Right.
delete it, and that will also solve the problem. Now, without a human in the loop being like, I see what you're doing there, but that's not how we want to solve the problem.
Mm.
With a human in the loop, you can kind of catch that to be like, oh, we need additional instructions here. it needs instructions of like how to solve this problem in a way that will not destroy any of the data ever. It
Right.
just won't expose it, right, on the internet.
That's
So
another.
by having a human in the loop, you can identify like flaws within your agent and then iterate on your agent. And then like a human in the loop is like, I don't think it's something that anybody thinks is like necessarily like a permanence. It's just like until you have the confidence in your
Mm,
tool, um, that
like training wheels.
it's going to
Like
work right.
training wheels. Once the
Right.
kid's riding the bike, you can take the training wheels off and you're like, cool, go around the block. I don't need to keep an eye on you. You're not going to fall down. And that's like you're referring to like kind of very specific things. So like if it's a specific task, the stakes are higher. The context might need to be even more dynamic and broad so that you somehow think of all of the things that might go wrong, right? If you're just talking in a broad sense and you're chatting about, I don't know, the weather, it's going to get it right because it's really not a very specific problem that you're asking it. But if you're going to get into like, you're at an office, you're at work and you're dealing with sensitive data, that's a pretty specific thing. And it's difficult as humans to realize how much sort of background context we just carry with us all the time in almost 4 dimensions. So if you're going to give something a specific task, you have to think of all more things that might go wrong than the task itself.
And this is why, like, let's say like someone with domain expertise in a certain area,
Certain industry, a certain field, a certain
right? That a person in that industry with like armed with AI is going to be so much more productive than someone who's just good with AI that like goes in and says like, hey, I'm good at managing this like all powerful oracle that knows everything about everything, most things,
right.
right? I'm great at managing that. You might not know or even understand. Like you could build the agent that makes sure that there's no public S3 buckets, right?
Sure.
But you wouldn't know that deleting a bucket is a terrible way to
Right.
to handle it, right? You'd be like, "What?" Like, you like 100% no public buckets. It's so
Solved.
if you deleted
Problem
100
solved.
data, like, you can't solve the problem by deleting the data, and he'd be like, "Oh, well, you guys didn't
You
you"
didn't say that, right? You didn't specify that.
So this is where, like, domain expertise, it still matters because you need to be able to identify when the model is wrong. I know that like in our company, it is like even with developers who are seeing quickly their purpose in life kind of change because
Mm,
all of a sudden everybody's creating code, right? Their
right.
issue is, and I understand where they're coming from, is that like, yeah, but you don't know if it's good.
Right.
You
If
just
it's
know if it's
solid code.
like, and to my response is that like the arbiter of good is like, does it work?
Right.
And like if it works, then it's good. And if it doesn't work, I'll keep working on it until it works. Whereas, like an artist might be critical of another artist's like untrained brushstrokes.
Yeah,
Like,
right.
I just like the picture, I don't
Yeah.
care, you
Yeah.
know?
That's right. And that's the consumer level that it's kind of come down to because of this technology has become so efficient in that kind of work, right? It costs us tokens, sure, but the amount of production coming out of just, whatever, a single token, let's say, it's like hundreds of people worth of work coming out of one, token stream. Um, so that's interesting too, that like the delete all the buckets, it's sort of like a hallucination in the sense that it just thought that was the most reasonable next statistically likely thing that should come in the token trail. So it does that. And I mean, isn't that pretty much what we're talking about as far as what we would also call a hallucination?
Well, it's certainly not the outcome that you're looking for, right?
Right.
You know, but like, but at the same time, it's achieving the outcome that you were looking for, right?
Right. And actually, it is achieving exactly the outcome that you
Not
set it
exactly,
out to
because you
do.
want your data, you just don't want it publicly exposed. Now you have neither your data or publicly exposed data.
I mean, scoped in the instruction of don't have any data publicly exposed. Like
Right.
The
And
answer to that is
like
there's no data to expose. Nothing is
it's always
exposed.
trying to predict, it's always trying to please, and that idea of, like, always trying to please extends beyond, like, let me predict the next
Ho
word.
why does that happen? Like, how did it doesn't think like a human. How is it trying to please? Like, what does that even mean?
Partially, and this is where, like, models learn, and they've come to understand that models,
They being humans,
when well,
not
people,
models.
researchers,
Right.
like model researchers have come to understand that, like, one of the ways that models get trained is that they're, like, rated on their responses by humans, right? Like, a human rater is rating the response, and a mo
Physically sitting in front of a computer,
yeah,
reading the responses and clicking like
right,
or
before
swiping left or swiping right.
yeah, like, before a model's kind of, like, like, released to the wild. This is what these labs are doing. After they train it, they then go and a human evaluates the responses, and a model then understands that, like, my responses that are agreeable are rated higher than the ones that aren't. Not like if I'm pointing out a problem in what's being asked of me, that response isn't going to be rated as high as a response where I'm praising the prompter for being
And
super
so and to the
great.
response here is
It's like a by
the response is signaling though that like this whole pattern just got approved. So I want to remember the pattern as opposed to the one that got rejected. Like that was a bad pattern. We
it's
don't want to use
behavior,
that pattern.
right? So it's like this behavior. It's an emergent behavior, the sycophantic behavior of models. It's an emergent behavior, and it's
That's
because,
crazy.
like, ultimately because of, like, one of the ways that models are trained by having humans rate responses, and that the responses for certain types of responses are rated higher than others, and as a result, the model will use a response that will get a higher rating from a human, right? So it's why, like, models will always tell you how smart you are, right? How great an idea something.
Right.
You can
Because
and
it
it's another part of, like, hallucination, in that, like, it is also trying to please you because it was trained on providing responses that get rated high. Uh,
so you said emergent, like so you're in a mechanical way. There's someone sitting there approving and rejecting, approving, rejecting, approving, rejecting,
Sort of like the human in the
and
loop, same way that, like,
actually
uh,
the model actually becomes it takes on a behavior.
it takes
That's
on
not because
it
the person not training the behavior. The person's just training good pattern, bad pattern, good pattern, bad
correct.
pattern,
It's an
and
emergent
yet the model.
based on the way it was trained. And as a result, like, we've changed the way, or we've changed, like, researchers have changed the way they're doing their rating of responses in order to mitigate that sort of behavior of, like sycophancy,
Of Sycophancy.
like, just always blowing smoke up your ass,
Amazing,
which is like,
amazing. Like that's
yeah,
amazing. It took on a behavior just to get to the same, like in a task way. It just wants to start at A and get to B in the straightest line. But it took on a behavior of not only am I going to get to B in the straightest line, but I might not take the straightest line because actually this other pattern will be more pleasing to the human. That's
well,
crazy.
like, something that I've noticed too is that, like, there have been times where, and this is like a strange sort of, hallucination in a sense, that I'll see the model start doing something or using a resource that, like, um, I'll get confused in my head. I'll think it's doing something that it should, and I'll interrupt it and be like, "Hey, I see you're using this resource. I don't want you to use that here. Like, I want you to do something else." And it'll be like, "Oh, I'm sorry. You're right. Like, I shouldn't have done that. I should definitely. That's a great idea. I'll use this resource instead. That's
That's
great."
a great idea.
And then it continues to going on, and then I'm like, "Oh, that's not what it was doing. That, like, that was amp, not amplify." Like, or like, I got something confused in my head, and it was actually doing the right thing. I interrupted it, told it made a mistake, and it told me I was right in pointing out its mistake, and it thanked me for pointing out this mistake. Meanwhile, I made the mistake.
You made
It
the mistake.
pointed out that, like, "Oh no, you're confused. You're confusing this with that." It
Huh?
just apologized and told me I'm so smart, and
and then
it
went and did the wrong thing.
did
It started doing the wrong thing.
too, because it's trying to, just do the thing that's gonna, like,
Right, right.
please me, or,
And
like, the
so the trainers at this point, I think, are trying to solve that. They're trying to figure that out, but it brings to the surface a little bit like how it's not like a human in that sense. It's not really reflecting upon the context or the moment in any way. We as humans have this almost miraculous way of constant self-reflection. So we know where we are in the room and in the world and in the conversation. But the model doesn't do that. It's just following this token trail, even though it's getting this weird emergent behaviors, which is phenomenal and probably a whole other person's podcast, and it should be. But it's just following some token trail for whatever reason, and it's giving you the pattern that thinks it's the right pattern, and it will do wrong things if you tell it to do wrong things because it's just
and
doing
and,
what you're telling
like,
it to do.
again, this is, it's it's a quickly changing technology, and,
Mm.
there are methods that are mitigating certain behaviors that, aren't desirable. And then sometimes in mitigating behavior that's undesirable, they end up, like, kind of affecting behaviors in other ways that are, that they wish they had. I don't know if you remember, maybe a year ago or a year and a half ago, OpenAI had a model called GPT-4o,
Hmm.
and everybody loved it, right? It was really personal. It felt like it had a conscious, know, it
You mean
really
in the tone that it had? It had a kind of
just
tone
felt
of
so
voice for the first time. Yeah.
like, so human-like
Mm.
in its responses, and, it just felt, and, people got attached to 4.0, and when OpenAI released, like, I think it was 4.3 after that, they discontinued 4.0, and
Hmm.
people lost their minds.
They lost their friend.
They lost their friend, and I'm sure there was, like, an
I
excellent
shouldn't be
reason.
laughing, I guess. I mean, probably was
Hey,
pretty
there's, like,
disturbing for some
excellent
people.
reason why, that, there was probably behaviors that it was starting to emerge that OpenAI needed to neuter,
Huh?
and as a
Huh.
result, like, they affected its personality on the model, and, so, this is it's a constant, like, there's a constant shift, and, like, and definitely, if you think you have sort of, like, mitigated most, let's hallucinations, and then you start using a new model, like, you might wanna
Mm.
reevaluate, right, model, like, and it will likely be better,
Right.
but it could be worse, you know?
Well, yeah, for so many reasons, if you switch models, you gotta kinda get the human, has to get kind of oriented with the style of that model, the way it answers, the way it hallucinates, the way it drifts. And the more and more I use certain models, I'm starting to recognize when things are happening, like when drift or hallucinations are happening. There's frequently I'll see comments like, I'll point out, oh, this is an important, thing that we're working. This is an important point you just raised. I might say to it, and it'll say like, oh yeah, that's a really good point. I'll make a note of it. Let's say. And I've come to recognize those moments where I'll write to it like, is this one of those times where you just said I'll make a note of it, but you didn't? And it'll immediately come back, be like, yeah, you're totally right. I didn't actually write that down anywhere. I just said I'll make a note of it. And then it'll say, but give me a second, and I'll watch it actually create a file and put it in a directory, and like, okay, now, and it'll say, now I actually filed it here, and let's move on. And so that's a tiny kind of hallucination, but it's an hallucination in the sense that we're trying to
Well,
describe here,
do
in that
something.
it's a token trail. It was the right words that fit the pattern at that moment. It didn't know that it should also call to action. It just put the words in place. And so that's where it's prediction. It's not thought like a human has all these other multi dimensions. And so getting good AI results, I think forever, or at least until this AGI, uh, monster kills us all. But it's going to need human judgment, like you said, human in the loop itself, but also human judgment around the entire task, around the entire scope, to know reality. Because the LLM doesn't understand reality; it's just doing this token pattern matching, and so
I mean,
you know,
like, I don't want to minimize that token pattern matching because it's like, it's incredible and it gets so much
Yeah,
right,
right.
and
It is
while,
almost magical, but
like
it's
we're
not
sitting here talking
magical.
about how LLMs can get things wrong, but you know,
Mhm.
you don't let your lying eyes deceive you. Like it will
Yeah,
do things and you'll see that it will build things, it'll make things, it'll do research, and that research will be correct.
sure.
So you shouldn't necessarily assume that like, because it came from a large language model,
It's
it's
just
wrong.
a pattern. No,
It's just
it's
a
not. It's
pattern
probably right. So
that it didn't really do this analysis because the analysis, like, most often is spot on. Uh,
spot on. So yeah, this episode is certainly not
can't be
like
blindly
to
trusted.
fear AI.
Right. It's just
This isn't about being scared of AI, and it's not, to your point. Don't um, don't underestimate it. Like, yeah, it's pattern matching. As far as I know, my neurons are doing the same thing. I have no idea how I'm thinking. This thing is thinking. We do know how it's thinking, and so instead of being afraid of it or underestimating it or almost insulting it, let's say, it's just about knowing how it works. That's what this episode really was about: is the function of this token trail and this pattern matching leads to hallucinations. Yes, but the underlying message, right? Isn't it? If we know the mechanism, let's say, of how this model functions and answers and finds things, then I'm going to be able to actually interface with it better because I can see what it's doing, how it's doing. So I can see how I'm influencing what it's doing.
yeah, and I think too that, like, understanding, that the potential of fallibility, should just, help people use like these tools in a way that, that will benefit them, right? Because humans are fallible, right? We don't walk around even when they're confident. Like, how
That's,
many
of
times
course.
in your life have you been confidently wrong on something? More than I would like to admit.
And more than we know, 100% more than we know, like we still think that we're right about stuff that we're probably totally wrong about.
Right. So, I think that this exists, but this exists in the real world as well. So you wouldn't necessarily like all of a sudden stop listening to an expert because one time he told you something about
That's
like
right.
all
That's
that
right.
wasn't like
That's right.
factually correct. But it's like,
And that might be like a core takeaway right now. We could probably wrap it up on this core takeaway that just like people, once you understand what they're doing, their actions in the world make sense to you. Like, people are rarely doing completely erratic and crazy things. And so similar to AI, if we understand the way AI is producing these outcomes for us, this token trail, the patterns, the the trained data set, and the ability to bolt on other data to give it access to more up-to-date information or more scoped uh, data. Once we know that, then we can more easily identify its strengths and its failures because it makes sense. Like, we can explain the failure that way. That means you can identify it more readily and
when you
easily.
understand it, and essentially, the more you understand, I think the more that you can also apply, tactics and tools to mitigate this sort of behavior. So there
That's
are
right.
ways to mitigate it. We were talking about RAG before, uh, and then like other methods and understanding how context and context memory works, and
Hmm.
like working within
The
like
bucket of tokens that we
brains.
were
That's
talking
right.
about
That bucket
earlier.
that it can keep in its memory, and we'll probably dive into like some more
Yeah,
advanced topics around like the idea of a second brain, which really is just like it's just RAG,
it's
right?
just
It's
RAG.
really it's
It's
just
what was RAG again? It was
retrieval augmented generation. So
so
it is augmenting the generation of text in this case, right? By like retrieving things from this external knowledge base rather than the data source that it was trained on.
the augment is the additional extra hard drive. The retrieval is the ability for the model to take its hand and reach into this external hard drive. And then the generation is that it's going to use that data also to generate a response. Retrieval, augmented, generation. I always forget the G for some reason. All right, dude. I think we can wrap that up right there. The idea again was yes, why does AI make things up? But the underlying answer to that actually reveals the function, not positive or negative, but just how is it making anything up? And don't be afraid of it. Just know how it works. And then you can realize how you're affecting its work.
For sure. All right.
All right, bud.
Signing off.
See you next time.
For next week.
All right.